All right, so the problem I'm trying to solve here is given a 25 kilogram block traveling at a constant speed while being pulled up a 45-degree angle slope, find the coefficient of friction and the force of friction. The block is being pulled at a force of tension of 200 newtons. So first off, we can find the normal and gravitational forces. So because the block is 25 kilograms, we know that the gravitational force pulling it down is that mass times gravity. So times 10, we know that the force of gravity is equal to 250 newtons. However, there are other gravitational forces at play here because the block is on a slope. So we know that there are also forces that are pulling it perpendicular and parallel to the slope of that the block is on. So those also go at a 45, 90 triangle. And because that's an isosceles triangle, we know those are equal. So we'll call this force of gravity Y and force of gravity X. And those are both equal to 250 divided by root 2 newtons. 250 divided by root 2 newtons. Now, to find the normal force, we know that it must be equal to this opposing force because that's what's keeping it up on the slope of the surface. So it also must be equal to 250 divided by root 2 newtons. So now we can get down to finding the coefficient of friction and the force of friction. We know that the force of tension that is pulling the block up is 200 newtons. And we also know that because the block is traveling at a constant speed, that the net force must equal 0. So that means that any force that is opposing the force of tension must also equal 200. So we'll say that 200 must equal the force of friction plus any other forces that are opposing it. We know that there is a gravitational force that is going parallel to the slope of the surface and to the force of friction. So we see that as 250 divided by root 2 newtons, but that actually ends up being approximately 176.776 newtons. Just put my units in there. So that means that the force of friction ends up being 23.223 newtons. And from there, it's simple to find the coefficient of friction. We'll just divide the force of friction by the normal force, and we will get approximately 0.131. So here we have the coefficient of friction, and here we have the force of friction.